Hi, and welcome to College Algebra 2.5, all about vectors. So what a vector is a arrow that has a magnitude and direction. A magnitude being how long something is, and a direction usually presented by theta to give me some sort of angle so I know where I'm going. The nice thing is they can get a vertical component, which would be in the y direction, and a horizontal component, which would be in the x direction. Because what it comes down to is a vector is this piece right here. This is the vector. And so we get this theta giving us that direction, and we can always construct a right triangle where we get the vertical, or so the horizontal and vertical components with the x and the y. So let's take a look at some. A vector, again, direct line segment. So for example, here, this is 50 miles per hour would be the magnitude. And then here is our direction. It says north 45 degrees east. So remember, north is where I would start, and 45 east is the way it goes. So that's why the 45 is right there. Here we have 50 miles per hour south, so it just goes straight down with a magnitude of 50 miles per hour. Also with vectors, magnitudes are usually speeds, so that's what it's usually on. Okay. So vector v, right there, it's usually a velocity idea, so velocity meaning speed. Um, yeah, yep, magnitude is speed. Okay. So we get this angle, and like I said, we get the y and the x components, x being the horizontal and y being the vertical components. However, now, sorry, not however. So the nice thing is a right triangle. And so if I know this angle and I know this piece right here, I can use other pieces. Well, what if I didn't know this? Let's say I knew this was, I don't know, like 15, for example, and this was 25. How would I find that side? Well, conceptually, this is just a right triangle. So I can use the Pythagorean theorem. So I would get v squared equals v sub x squared plus v sub y squared, and I would square root both sides. So that's all what this formula is saying right here. The magnitude of v can just be solved by Pythagorean. So while it looks a little different, it's already a concept you're familiar with. Now, let's say I knew this. This was, I don't know, 35 degrees, and this was 15. And I was trying to find x or y. Well, from the perspective of theta, this v would be my hypotenuse. The y is my opposite, and the x is my adjacent. So if I was trying to find x, I have hypotenuse, and I'm looking for the adjacent, I could use cosine of theta equals adjacent x over hypotenuse v. I can multiply both sides by v. So we find that x equals v times cosine of theta. Following that same logic, y equals v times sine of theta through SOHCAHTOA, which is what these formulas are saying right down here. And of course, if I knew what x and y were, so for example, 15 and 25, that's my adjacent and my opposite, I can use opposite and adjacent, that'd be tangent of theta to find that angle. So while this slide has all these different formulas, these three formulas here, four I guess, it's really just an application of the Pythagorean theorem and SOHCAHTOA, something that always comes up in all right triangles. So even though the labels are a little bit differently, don't let that confuse you. A human cannonball is shot out of a cannon with an initial velocity of 50 miles per hour at an angle of 60 degrees from the horizon. Find the magnitudes of the horizontal and vertical components of of the velocity vector. So find the magnitudes of the horizontal, so aka the x, and the vertical, so the y, going to the velocity vector. So from the horizon means from the x-axis, because the x is horizontal, and the horizon will be there, so that's why the 60 is right there, and this is 50 miles per hour. So from the perspective of the 60 degrees theta, we have the hypotenuse. We need to figure out the opposite and the adjacent. So I can use those formulas we just talked about. We get the x is v times cosine of theta. So I'm going to get 50 times cosine of 60, which gives us 25. And y is my opposite, so I have to use v times sine of theta. So I'm going to get 50 times sine 60, which is about 43.3. Now, you may notice that I went from cosine 60 to 1/2 and sine 60 to root 3 over 2. Those can be found on the unit circle. Otherwise, it's still just a typing into your calculator thing, as long as you're in degree mode. An arrow is shot into the air, so its horizontal velocity is 25 feet per second, so that's our x, and its vertical velocity is 15, so that's going to be our y. Find the velocity of the arrow, and the angle of elevation of the arrow. Remember, angle of elevation means to go up from the horizontal, so it's going to be that angle right there. So, again, we have our opposite and our adjacent, and this is our hypotenuse. Well, it's a right triangle, so I can do Pythagorean theorem. So we get v sub x squared plus v sub y squared equals v squared. And we could square root. So we're going to get the square root of 25 squared plus 15 squared. So we get v is about 29.2 feet per second. Okay. And then finding theta, I can use opposite and adjacent. So I'm going to get tangent of theta equals 15 over 25. So theta equals tan to the -1 of 15 over 25. So we get about 30.96. Let's say about 31 degrees from the horizontal. Okay. What are other vectors? Force is acceleration multiplied by mass. Famously, force equals mass times acceleration from Sir Isaac Newton. It's often defined by pushing or pulling an object. Work is the amount of force applied that causes an object to move. So work is the force applied that causes the object to move. So we find that work equals force times distance. Force times distance. Okay. So when work is applied in a straight line, it's usually pretty easy to calculate because it's the force tends to be 1-to-1. Besides, like, when you have forces acting in the other way, if we're talking about like friction and stuff like that, but usually it's pretty 1-to-1. Now let's say we're pushing a chair and we're pushing downward in a diagonal. Well, the chair is not going to go through the ground. Its displacement is going to end up going along the ground in the horizontal direction. Push it by a different color. So how can I find this piece? Well, if I were to construct a right triangle, we find that that distance is the same direction, so it must be the f of x right there. So we need to figure out f of x. Well, again, this is my hypotenuse, and this is my adjacent. So if I know theta, we find that f of x can be found by f times cosine, because again, adjacent and hypotenuse. And it's kind of nice because the x direction is cosine still, just like it was earlier in this lesson. So we find that this is the force that matters. So when I go with work equals force times distance, this force piece gets replaced by F cosine of theta. So our formula gets slightly more complicated when you're applying force at an angle. If you're just applying force traditionally in a straight line, you can just use force times distance. Thank you for listening, and I hope you have a great day.